let's now continue through our notes, which reads, we now look at two special types of trails and circuits, which are most commonly used in modeling problems using graphs. So they're called Eulerian trails and circuits. Now, trails and circuits both had a characteristic, and that characteristics of both trails and circuits was that you can repeat vertices. So let's write that down. The fact that we're dealing with trails and circuits means we can repeat vertices. All right, so let's begin by talking about the Eulerian trail. So an Eulerian trail includes every edge exactly once and starts and finishes at different vertices. So those are the two characteristics of an Eulerian trail. Every edge exactly once and starts and finishes at different vertices. Now, for that to occur, the graph must be connected. So let's write down here, if it must be connected, that means we have no isolated vertices. And then you can go slash disconnections. Everything must be connected. Disconnections. What else must we have here? So we'll keep reading. The graph must have two vertices with an odd degree, and all other vertices must have an even degree. So this is an interesting characteristic as well. In order to have this Eulerian trail, we need two vertices to have an odd degree, and all others must have an even degree. All right, what else do we have for an Eulerian trail? We'll always start and finish at the vertices with an odd degree. So an Eulerian trail will always start and finish at the odd degree. And then finally here, it says vertices may be repeated, and that's what we wrote up here. Now, we also need to consider something called an Euler circuit. So an Euler circuit includes every edge exactly once and starts and finishes at the same vertex. So already you can probably tell what the difference is, just on the face of it, between an Eulerian trail and Euler circuit. One starts and finishes at different places, and the other finishes and starts at the same place. Okay, let's read this. Here it says, the graph must be connected. So in the same way, the graph must be connected here, no isolated vertices or disconnections, and all vertices must have an even degree. So this is different to what we saw up here. So now all vertices must have an even degree, and we'll be seeing that soon in an example. And then the last one here, vertices other than the start and finish may also be repeated. So vertices other than the start and finish may also be repeated. Now, important for us to know here, and it's kind of given away by the fact that all vertices must have an even degree here, while for up here, we need two vertices with an odd degree and all others to have an even degree. It's never possible for both an Eulerian trail and an Euler circuit to exist in the same graph. So let's write that down. I'm going to turn my screen around here. Whoa, if my computer lets me do this. And I'm just going to do this. I'm going to do this. And what I'm going to write here is never. Look at that, I'm writing sideways. Never possible for both to exist in a graph. Okay, so now having read those definitions, let's now jump into some examples.